All right, what's up, everybody? So today, that was a pretty good YouTube what's up, everybody, if I do say so myself, a good old YouTuber what's up, everybody. But yeah, so what's up, everybody? Today, welcome to Thursday. Really what we're doing today is we're practicing Newton's second law. I tried to come up with like a fun little like, hey, this is a phenomena associated with it. But I couldn't really think of a good one, and pretty much everything is associated with Newton's second law. So today we're just kind of building up a practice, and then probably tomorrow we'll kind of combine kinematics and also look at like, hey, here's a realistic situation. Let's analyze this. So yeah, so what we're doing is just a quick little review of Newton's second law. And then I have a Google form that has 5 shorter practice questions and then one kind of like quantitative, qualitative style free response question. And I'll just kind of today on this video is going to be really short. And then the rest is just going to be like, hey, here's this first practice question. Here's the key for it. So if you want to watch all of them and be like, hey, I want to hear this explained, maybe that's a good idea. Kind of refresh your mind about, oh, what is this like? What's it? How do we do this? How do we set this up? How does this work? And then, yeah, but really all you have to do is the Google form. And then if you want to watch these videos and kind of hear my explanation and me going over them again, I think it's a good idea just because it's been a while since we've done Newton's second law. And these have some little complications to them. So pretty much really all we're doing with Newton's second law is this main idea. It's this idea that tells us force causes objects to accelerate, and this acceleration is directly proportional to the force F and inversely proportional to the mass. So if we have more force, we have more acceleration. If we have more mass, then we have less acceleration. And that's dictated by our Newton's second law equation. This F net equals mass times acceleration, or as it's stylized on the AP equation sheet, A acceleration is equal to the net force divided by the mass. And, oh, I guess I have this example video, but it's stupid. I don't like it. It's just a kid kicking a bowling ball. Don't love that. So this has a lot of mass, applied some force, but the bowling ball didn't really accelerate, and he probably busted his toes, and I don't like that. But whatever. Okay, so then when we are doing Newton's second law, in order to actually do it and use it, what we have to do is we have to circle the object, draw that force body diagram, identify the net force acting on the object, and then use our F net equals mass times acceleration equation. So it's kind of like what we did when everything was balanced. The only difference is that we have a net force. Things won't balance out. And instead of it equaling 0, instead of the up equals down or left equals right, we have that net force has to equal the mass times the acceleration. And when we're doing this, the direction of these forces, it does matter. So if something's pointing up, we can call that positive. If something's pointing down, we can call that negative. If something is to the right, we can call that positive. If something's left, we can call that negative. And really keeping track of the sign is going to be one of the hardest and most important things for us to reconsider. So when we're thinking about the acceleration, that's really where a lot of us got tripped up. If we see that our object is accelerating down and we're defining down as negative, we have to make sure that when we set it equal, our F net equals mass times acceleration, we're setting it equal to a negative acceleration. So that's kind of this intro video. The rest is just going to be me kind of being like, hey, here's practice question 1, pause it, try it out, and then I'll go over it. But yeah, so I just want you to kind of watch these key videos and yeah, get some practice doing these ideas. Because again, it's been a while since we've done Newton's second law, but it's very important and it's a big idea in physics. So yeah,